right? All right, first thing up for today, we are going to talk about volume, which is good, and here's why. All the volume formulas you need are going to be on your reference sheet. All right, you are going to get the most use of that reference sheet right now and in the rest of this unit. Okay, there are still a couple formulas to memorize, but most of them will be on your formula sheet already. All right, so what is volume? What was surface area? Everything on the outside of a figure. Now we're going to go through the same figures and introduce the sphere too in a couple days, but now we're going to do how much does it take to fill it up? Okay, how much does it take to fill it up? And before I do today's two polyhedrons, which are prisms and cylinders, I want to talk about this principle right here. Cavalieri's, that's the guy who founded it, principle. Here's basically what it says. I'm not going to spend too much time on it, but I want you to be aware of it because it has come up on the Regents exams in the past. No matter what a figure looks like. Okay, look, I have 3 rectangular prisms. Everyone agrees? One's just standing straight up. One is a little bit tilted, and I'm not too sure what the deal is with this one here, but just because this one's tilted and this one's straight up, they have the same volumes. Okay, probably an even better example. Look at these 3, I don't even know, cardboard boxes, pizza boxes. Nice and orderly, right? A little bit of a lean, and then a hot mess, right? Everyone agrees? Probably any of us in here could fit in one of these 3 categories, right? They all have the same volume. They all have the same volume. Why? Here's what Cavalieri's principle says. If all of these have the same height, which they do, all of them have the same height. And remember talking cross-section on the quiz? If I took a cross-section here, found the area, took a cross-section on the second one, found the area, and took a cross-section on the third and found the area, if all 3 areas are equal, they all have the same volumes. Okay, so if I took the area here, area of this cross-section, and area of this cross-section, they all have the same volumes. Okay? Talking about it doesn't do me much. I like a visual. Take a look at these 2 bad boys right here. You would not think they had the same volume because they look totally different, right? Everyone agree? Well, take a look. Do they both have the same heights? If I took a cross-section here and held it up, what would it be? Triangle. If I took a cross section here and held it up, it would be a with the same area. So they're going to have the same volume. Okay, and that's what Cavalieri's principle says. Same height, same area on each cross section, same volume. Okay, so everyone good? Yep, everyone likes that. Good. They actually do have the same volume, even though they look totally different. Okay, and we don't need to go back and forth. And then finally, it still works even if they're not the same shape. I've been dealing with same shapes up here. This is a triangular prism. This is a rectangular prism. They have the same volumes. Why? Same height. And now take a look. If I took the cross section here, it would be what type of figure for the prism, triangular prism? What's the shape of the cross section here? So triangle area equals, what do I get here with the cross section? Equals the rectangle area. All right, those 2 together give you same volume in Cavalieri's principle. Same height, same cross section area, same volume. All right, so that's Cavalieri's principle. Two figures will have the same volume if their heights are the same and their cross sections have the same area. Here's where it came up on a Regents a couple years ago, right here. Example 1. You guys can flip over your packet for me. All right, take a look. You got 2 stacks of 23 quarters. One stack forms a nice, beautiful cylinder. The other one is just pretty messy, right? But why do they have the same volumes, even though they look nothing alike? One's all messed up. One's nice and stacked. Well, why do they have the same volumes? They have the what? Same height. Everyone agrees? 23 quarters each. Same height. All right. Take a cross section from each of them. Hold it up. What would it be? Circle with the same areas, wouldn't it be? Everyone agree? If I just took a handful of quarters, held it up, there's a circle right here, circle, same area. So cross sections have the same area. That's Cavalari's principle. Why two objects have the same volume. They have the same height and they have the same area for their cross sections. All right, we all good? Spent too much time, but I want you to be familiar with it, hear it, in case it comes up during our regions review. All right, let's get to the meat here. Prisms and cylinders again. Look back. Here you go on your reference sheet. Let's start with a prism. What's the volume of a prism? Look back on your reference sheet for me. Volume of a prism. Get used to going to that thing. 4, when you're ready, volume of a prism. On the reference sheet. Yep. Should be last page. Volume of a prism. Okay. It gives you big B and lowercase h. So let's talk about what each mean here, because it's one thing that I give it to you. It's another thing, how do I use it? Capital B is the area of a base. So if it's a triangular prism, find the area of the triangle. One triangle, area of a base. H, I know everyone's going to yell out height, right? But height of prism. Height of the prism. So the edge that connects the bases. All right, edge that connects the bases. All right, so let's do them both right now because they're on the formula sheet. Cylinder now. Volume of a cylinder. What do you got? 11. Volume of a cylinder. Yep, it's BH basically. BH, but B is a circle, so pi r squared times the height. Questions on those two volumes? Because I'm going to just go over a few examples and then you can get going on the homework. All right, find the volume of this prism. Name it first. Name it. What type of prism am I finding the volume of here? 1. Triangular prism. So everyone got V equals BH. Remind me what capital B stands for again in this formula. 1, George again.
Area of a base.
A base. And what's the shape of the base?
Triangle.
Triangle. Everyone agrees? So for the first couple, I'm just going to do big B over here. George said it was a triangle, so I'm going to do 1/2 base times height for that triangle. All good where that's coming from. That's the area of a triangle. Big B represents area of a base. What are the base and the height of that triangle? Well, George, 3 for 3.
15 and 8.
Legs, right, of a right triangle are the base and the height. So 15 times 8. Okay, everyone good. That's big B. That's capital B. Area of that triangle right there. 1/2 base times height. Now, what about this H right here? I'm not looking for the number. Tell me what it represents, though. What's that H represent? 12? Height of the prism. So look for the edge that connects the bases and tell me how long it is. That's the height of the prism. 7, height of the prism. This 8 right here. That's the height, everyone. That's the height of the prism. That's this H right there. Everyone good? All right. Let's see if I can catch you on the answer. George. Oh, boy.
480.
Are we doing surface area anymore? We're doing volume. Cubed now. Surface area, lateral area, squared, volume, cubit. Cubit. Yeah. All right, you guys ready to get nuts here? Because I don't fool around here. I'm not spending time finding all these volumes. I want to get right to some crafty problems here that'll make you think. I got the pool. No, you guys don't have that, do you? Yeah, you do. All right, you do. Okay, volume is, there's the volume, length, width, and depth. Oh, what have we been doing all year? Numbers in a ratio. Numbers in a ratio. What have we been doing with them? We'll continue to do it on the regents. 14, 10 to 4 to 1. What do I do with them? 10x to 4x to 1x. Yes. There's your length, width, and depth. If you don't have it already, get out those calcs. 1080. What are we going to set that equal to? How do I find the volume of this rectangular pool now? 8, 10,080 equals?
15x.
Ooh. Ooh. How do we get 15?
The 10, 4, and
You're adding them?
x. No.
What's ready? There you go. I should have probably drawn my rectangular pool here. What's capital B?
Base. So 10, 40.
Times, correct? Everyone, yes? Times 10x times 4x. And then what about your height? So don't add them on me. Okay, don't add them. Everyone's good? I do get 40, but I get a little more than 40. Algebra studs in the house, 40. X. How many? 1, 2, 3. 40x cubed. Next move. 8 again. Next move. Come on. Now redemption.
Divide the 40.
Get the 40 out of there. Get the x by itself. X cubed. What's that number there? I'm not even going to guess. 27. All right. I don't think I've shown you this year. If that was squared, we take the square root. We're done. But now since it's cubed, we got to take what's called the cube root, which is like a square root, but the 3 in the middle there. So I need to show you on the calculator, how do I take the cube root of a number? Hit your math button, and you'll see it right there. How is it? 4? Choice 4 nowadays? Yeah? Okay, so it's under your math button. Cube root is under your math button. So x equals 3. Come on, I need your regents ready. 4 weeks from today, by the way. 4 weeks from today, regents ready. Here's the problem. Yay, I found x. Let's have a party. No, you didn't get full credit. You didn't answer the question. You're not done most of the time when you find the variable. Find the dimensions of the pool now. If x is 3, what about its length, width, and height here? Let's roll. 3, talk to me here when you're ready. Length, width, and height.
35 plus
30, 12, 3 meters, right? Meters. Wow. We all good? I guess we'll have to suck it up then, huh? Right. All right, Jed's up. He bought a little generator. It can run for 12 hours. Wow, on a liter of gas. Rectangular prism generator. He's going to fill the tank with gas. How long is it going to run? And I gave you a little conversion there. 1,000 cubic centimeters is 1 liter. All right, well, stop. I know it's volume day, but in 4 weeks, you're not going to know what type of problem it is. What up here says this is a volume problem and not surface area? Anything up here you recognize that says volume. Hello, Luke.
Says it fills the tank with
Okay, fills it inside with gas, inside, right? We're not layering the outside with gas. And even if you didn't see that, everyone see my conversion there? Cubic centimeters, got to be volume. All right, help me find the volume, BH, of the generator so we can do something with it. 6, how do you find the volume of the generator? There's big B, and then multiply that by 10, the height of the prism. It doesn't really matter the order. You're going to multiply all 3 anyway. What do we end up with here? What's Jeb's? 15 times 20 times 10. 3,000 cubic centimeters. It runs 2 hours on a liter of gas, so I need to put that into liters now, don't I? Everyone see the conversion? 1,000 cubic centimeters equals 1 liter. And look, I get it in here. Some of you are probably going to be nervous if I called on you and said, do you multiply or divide by 1,000? It'd be a guess, 50-50 shot. Don't make it a guess. Here's how. I want you to make a proportion out of it. Write the conversion first. Ready? 1,000 cubic centimeters equals 1 liter. Make a proportion out of it. What's the 3,000 out of? What units is the 3,000 out of? Here we go. 2. So it should go under the cubic centimeters in your proportion. How many liters does that make? Okay, and then you can cross multiply. Guys, I'm telling you, please do it every time if you're nervous about what to do with the conversion. All right, I know you are. Do I divide? It's always the case. Do I divide or multiply? I don't want you guessing. Make a proportion out of it. When you're ready, after you're done cross multiplying, how many liters of gas do I have? 13. When you're ready, how many liters of gas? 3 liters of gas. And we're not even done with the problem yet, are we? It will run 2 hours on a liter. 2 hours on a liter. So how many hours is this going to run for? If you're nervous, divide by 2, multiply by 2. 1 liter equals how many hours? Make a proportion out of it. I can't stress that enough. Liters under liters, hours under hours. Do I need to see this? No. But if you're not confident, write the darn thing down. All right, how many hours is this beast going to run on? Let's hear from 3. 6 hours. That's a lot. This is what you can face. This is what you're going to face here this last half of the unit. Last piece of new stuff for the year. Anything about Jeb? What do we got up next? Cylinder time now. Cylinder. Height of 7, base with the diameter of 10. What's the volume? And everyone see our answer has to be in terms of pi. So have a pi in your answer. Don't touch it on the calculator. Volume formula from earlier. 4, volume of a cylinder. Okay, let's plug and chug. Pi, what's my radius of this cylinder? Radius. 7.
Radius is 5.
5, half of 10, squared, and it comes right out and says 7. You better put pi in your answer right now. And what do you get with the pi there? 16. What do you have? Well, I got 7 too here, though. 5 squared is 25. You got to multiply everything but the pi. 25. 5 squared is 25
Yeah.
times 7. I got to multiply it all.
Is it possible to multiply 7 and 25?
That's what you're doing.
Okay, then so 175.
175 pi, units, centimeters cubed. Questions? Something different. Little thermos. Anybody still use thermoses nowadays? Anybody used to have like elementary school? Those, well, maybe you still do. Sorry, the metal lunch boxes used to have the thermos in there with it. Came with it. Whatever you guys were into back in the day. Yep. Yep. The old thermos had that flip up top spigot that you used to drink out of. Yep. Good old days, right? Had some Gushers fruit snacks in there. I don't even know if that, do they still exist?
Yeah.
That's
Fruit by the foot. Anybody like the roll up? Like just pure sugar, just hardened. Yep. This one may be too old school for some of you, but Dunkaroos. Oh, the Gran. No chocolate, of course, just the honey ones dipped in the vanilla. Good old days. Yep. Good days. Trading for other snacks, people at your cafeteria and your lunch table. All right. Anyway, good times. Problem here, though. Problem on this one. I'm not going to fill the whole thermos with coffee. I'm only going to go up to 1 inch from the top. All right. So I'm filling this bad boy up here. 1 inch from the top with coffee, not the whole thing. So what's the volume of coffee I have in there? Well, it takes the shape of a thermos, pi r squared times your height. Radius is 2.5, but the problem is nobody should be plugging in 12 for the height. Because that's the height of the thermos, not the coffee in there, though. What's the height of the coffee in there? 5, height of the coffee there, Jackson? 11, right? 12 minus 1, so I'm going to put in 11. Not too tricky, but just had to pay attention. 1 inch from the top. And we do have rounding directions. Ooh, 100th. This is a good one. 100th. When you're ready, 100th. 17.
215.98.
Do you have another number there? That's 10.
98.
98. Anybody else favorite snacks? How about the little cylinder-like dipping sticks in the cheese? Anybody remember that? They're like almost like, I would say like crapper. They were cracker texture, and you dipped it in the cheese. Opened up the plastic on the top.
So Oreo one of those.
Right there. Yep. Any other good memories? Lunch snacks?
Ketchup packets.
Okay. To each his own, I guess. Yeah. Alrighty, here we go. Got your barrel of fuel oil cylinder, right? And I give you a conversion, 231 cubic inches in a gallon. How many gallons is in one barrel of fuel? Again, I'm going to ask you guys again, why is this a volume problem? And I get it, today's volume of a cylinder day. But other than that, in 4 weeks on the Regents, what up here says you better find the volume of this? 15, anything up here say, yep, this is a volume problem. Because why not find the surface area of it? And what's in that conversion? 231 Cubic, 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 volume, volume, volume. Pi r squared times the height. I think, oh, I don't give you everything here. So I'll have to ask somebody. What's the radius of this barrel? 7, radius of this barrel? 11.25. Squared, height 33.5. Hey, everyone, are we done with this problem here when I calculate the volume? Nope. Why do I ask you that? Why do I ask you that? What are we not doing here? Rounding. Thank you. We're not rounding. We're not done. Pi times 11.25 squared times 33.5. 13,319.86198 cubic inches. All right, you ready? Again, I get it. You're nervous. What do I do with that 231? Divide or multiply, right? You're nervous. All right, I'm going to set up a proportion again. 231 cubic inches in 1 gallon. There's the conversion. Just write it. Just write the conversion that's given. Over. Where should I put the 1339 or 13,319? Under inches, because it's cubic inches. So this is getting placed right here. And I'm solving for how many gallons there are to the nearest tenth. So it looks like you end up dividing by 231, right? So to the nearest tenth, how many gallons can this barrel hold? 3? 57.7 gallons. Good work. Did I give you this next one? Looks like I did. Yep. All right, probably not going to be happy about this one, but welcome to the above average class. Here we go. 16, start us out. What's the volume of a prism? Volume of just any type of prism. Times? Okay. Remind me again, what is big B? What does that represent? Capital B. 9, what's capital B represent? Area of a base, correct? What shape is the base in this one? 19? Find the area of it. That's big B. The area of that hexagon right there is capital B. Okay, we got our little refresh here. Remember how to find the area? How many triangles is it going to make? 6 triangles times 1/2. Take a look. What's the base of one of those triangles already? Times 6 times now the height. All right, times the height. It's going to make a 30-60, right? 30-60-90. This angle here's the 30. Here's the 60 right here. Do I want to use 6 in the calculation here? Nope, divides it in half. You use 3, which is across from the 30, the shorter leg. So if 3 is the shorter, what's the longer then? The height. Do you remember your rules real quick? What's the height here? 7. What do I need to do to the shorter side to get to the longer side? Multiply by what? Radical 3. So what's it going to be? 3 radical 3. Okay, that's that's just big B. That's just capital B, right? There's the area of the base right there. Right? That was just capital B. 6 times 1/2 times 6 times 6 radical, or 6, 3 radical 3. That's just capital B. Now multiply it by the height of the prism, which is 3. Height of the prism, 8. Woo! What are we going here? 100th? 7. Again, you're up. 100th. Don't skip it tonight. Don't skip it. You know how to find the area of a hexagon. Okay, anything else? Because I'm going to let you do the last 2 on your own. Now, have I given you the formula, volume formula of an L? No. Okay, I had it. So what's the best way to try to find the volume of this entire thing? Cut it up into 2 prisms. Either you can cut it up this way, one on the right, one on the left, or cut it up going this way. All right. And then over here, I got good news for you. Remember with surface area, we always had to worry about what was covered up? Not for volume. Okay. On number 9 here, let me get you started on number 9. What's this figure here on the left? A whole one? Whole cylinder? No, so you're just going to find the volume of a half cylinder and add it to, what's this figure on the right? It's not a cube because all of them aren't the same. It's just a rectangular prism. Don't worry about what's covered up with volume. All right, go ahead. Get after it. We'll come back as a group here in a few minutes. If you want to talk to people around you, that's fine. Let me work backwards here. Let me start with number 9, especially the half cylinder, making sure we got the right measurements. It's half pi r squared h. So where's the r come from? The radius. Hey, everyone see this is 8 right here. This is 8 right here, which is the diameter of the cylinder. Cut it in half, you get 4. How do I know the height of the cylinder is 6? Remember the definition of the height. Connects the bases, right? The edge that connects the bases, which would be that one right there. 6, 6, 6. There's your height. So add them together. Total volume, 600 and... No? 79 cubic inches. Questions there? And then no matter how you split up number 8, what are we looking at here? No matter how you split it up. Take a stab at it. It's less than 100. There's your first clue of the day. More than 50. 76 cubic feet. I went like this, but you didn't have to. And if you went like this, I got 40 and 36 for my volumes. There's not much, as you can see from tonight, not much at all. Please check your answers. Make sure you have your Regents packet with you tomorrow.